Okay, I will show you some answers to these. Here they are.
Oh my goodness.
Oh, so it is 8 over
Minus 3.
Okay, so I put some boxes around some key items on your DMR. Be specific, you just put the input?
No, the input has more than one output.
Which input?
2.
There we go.
Because 2 has 2 outputs.
Mr. Anderson, so for number 2, you can, I was kind of confused. Like, I knew how to start the first part, but for
You mean finding the slope?
Yeah, for the second part, do you just plug one of those two
You can pick either point.
Okay, that
Yeah,
makes
so
more
it's,
sense.
point slope form,
I was
you
getting
can pick
confused,
either
like you had to
point.
pick one from each.
No, definitely don't do that.
Okay.
You want to pick one whole point
Okay.
or the other whole
Okay,
point.
that makes more sense.
Thanks for asking. Good question.
You lied, Julia.
Oh, this is getting personal over there.
I guess it's true, but like.
Was number 1 sort of a scary answer at first?
Well,
88/15ths?
well, because you can go back and check.
I mean, it just didn't make sense for
And
me.
then, like, you just have to, because you can't divide anything by.
Yeah, you do have
And you're like,
to.
oh, we're just gonna go with
It'd
it.
be even a tough one to check, right? But you could do it. You could navigate it. Sometimes people get weirded out because the answer is not 7 or 3, right? It's a fraction. But it's okay. All right. So questions from you guys. Had a couple. Yeah, go ahead, Bray.
I don't get number 4.
You don't get number. Okay, so let's talk about number 4. So number 4, if you think about number 4 at its core, is essentially a yes or no question, right? Is this relation a function?
I thought I put yes because for every input has only one output.
That's not true. Okay, hey guys, listen up.
2 has 2
Because 2 is 2 outputs.
2 has 2 different outputs, right? So check out your 2 right here. 2 has an output of negative 13, and then 2 has another output of 5.
So they would have to be the same.
If you had 2 comma 5 and 2 comma 5, it would still be a function.
Okay.
Because that's just, for some reason, a repeating of the same input-output. But if you've got an input mapped to negative 13 and an input mapped to 5, 2 different outputs, not a function. Is that good enough? I was going to write some stuff, but maybe that's...
That makes sense.
Okay. Okay, keep going. What else can I do for you as far as a question goes? Mason. How did I get what? Number 1? Okay, so let's look through my steps here. Can anybody tell back? I'll use a there we go. I'll use a bright yellow square for this. Is it bright yellow? No, it's not. I'll use a gray square. Are you sure? All I did was mess around with my pen tool on the iPad here. You figured it out? Okay. Fair enough. Anybody else? Now's a chance for you to express your frustration, your, I don't understand.
Can you simplify 88 over?
You can't reduce it. You could simplify it to be, and I would not recommend this. It would be 5 and 13/15, I think. Yeah, 5 and 13. You could put it into a mixed number form, but I don't recommend that. It's not going to reduce. I would just leave it as 88/15.
So you could just leave it as a fraction.
I would kind of prefer you left it just like that.
But what if it's not wrong though if you reduce, is it?
You mean put it? You can't reduce, but you could put it into mixed number form, 5 and 13/15.
Okay.
That would definitely be okay. I would prefer that you didn't do that, but it'd be okay. Well, what about number 2? Okay, so do you have a specific question on number 2? I've got my steps. Okay, good question. So the goal was to get slope-intercept form. And when I am right here, do you see how the y is not by itself?
Yeah.
It's got that minus 3 with it. How do I get rid of minus 3?
Add 3.
You add 3. So at this point, if I add 3, negative 3 plus 3 is 0. So wouldn't that make the left side just a y? But then I can't add 3 to the left side unless I also do what? Add it to the right side. So if I add 3 over here, what's negative 1 plus 3? That's where my 2 came from. That was a specific question. Did I get it okay? Okay. Anyone else? Okay. So before we jump into the newer stuff we're going to do today, I want to do some older stuff. I want you to think really carefully about the answers to these. You ready? You need to know the answers to these if you want to progress. Remember, our ultimate goal in this unit is to give you the skills you would need to make an informed decision about, should I buy a hybrid car or should I buy just a regular gasoline-powered car? But you're going to need to know these skills in order for that to make much sense. Okay? So question number 1. This is not in your packet right here. Just listen. Question number 1. What is a system of linear equations? Oh, here we go. Yeah, 2 or more equations graphed on the same graph, right? Graphed together. So system is 2 or more. And in our class in Algebra 1, on the 2 or more equations part, how many are we going to focus on?
2.
2. We're going to stick with 2 for the most part, okay? So you've got this lovely system of 2 linear equations, and you're trying to figure out what the solution is on a graph. What does the solution look like? The intersection points. So I heard Doc say that pretty clear, and Sebastian was saying something, Ella was saying something. I didn't hear a whole lot of the rest of you say much of anything. Hey, what's the solution to a system?
Intersection.
I was going for Sasha there, but
She has so much energy. She's ready.
intersection points.
She's ready for me.
Bree was on that. Bree was not going to be denied
Who said that?
that. Okay.
Attaboy.
Hey, Sophia. Sophia, what is a system of equations?
It's 2 equations.
Yeah. And what's the solution look like on a graph? The intersection. She knows what she's talking about. That's great. Were you all listening?
Yes.
You're all were listening? Okay. Hey, Trevor, what is a system of equations? What's a system of equations, Trevor? Shh, please listen. No. System of equations. We're going to let Sophia, maybe not Sophia, we'll give somebody else a chance this time. Kate, what is a system of equations? Oh, we got to have everybody on board. Oliver, what's a system of equations?
2 or more linear equations.
Did you hear that?
Oh,
Yeah, graph together. I'll be okay if you just say you've got 2 or more equations, right? 2 more linear
2
equations.
more equations graphed together.
Yep,
Okay.
that's right. That's right. Okay, so Trevor, what's a system of equations?
A system of 2 or more linear equations.
Yeah, there's 2 or more linear equations. That's right.
Graphed together.
They graph together. Caroline, on a graph, what does a system of equations solution look like? The intersection point. So, as we go through this, that was nice work. As we continue to work on these, I should be able to ask you that question anytime, and you should know what it means conceptually, know what that means as far as an answer goes, and we're working on ways to get there, okay? So, yesterday, we learned a new way to solve a system, and I used an analogy of like pizzas and volleyball match to maybe help you remember what that method is called and how it works. Does anybody remember the name of that method?
Substitution.
Substitution is correct. Well done, Noah. Substitution means that you are going to take one thing out and replace it with something else. But what's the requirement for the taking the thing out and replacing it with something else? The two things must have equal value. They must be equal or equivalent. That's the only way that substitution really works. Okay. Does anybody have any just kind of general questions about the things we've talked about in the last 3 minutes? Okay. So, I want to let you know that there is a third way to solve a system. So if you guys would flip over to the next page where it says practice 1.
Oh, I know how to do this.
Good. So, hey guys, listen up please. I want to show you one. Now I'll get you started on one, and then we'll see if you can finish one off yourself here today in class. Okay. So notice what the instructions say. Solve the system using elimination. It doesn't say substitution. It does not say graphing. Those are the other two methods we learned. It says elimination. So when you hear the word elimination, what does that make you think of?
Get rid of it.
Taking something out, getting rid of something. Something's going away, right? Something's going away. I mean, boy, that would be bad if somebody told you, "Hey, you've been eliminated," right? Like if you played on a sports team, or you were on like the theater, the arts team, and your coach, whoever, said, "I'm sorry to tell you, you've been eliminated." You guys ever seen the TV show Amazing Race? I used to really like that show. I haven't watched it in several years, but I remember at the end of each one of the little episodes, like the people run up to the little pad, right? And if they were the last one to arrive at the end, the host guy, he would say, "I'm sorry to tell you that you've been eliminated," right? And what does that mean for that group of people?
They're out of the race.
They go home, they're out of the race, they're not going to be on the next episode, right? They've been eliminated, they're gone. And so that sense of the word eliminated or elimination is the same sense we would use here, okay? So if you guys would, look at this system. Can anybody tell me anything unique you see about this system? Something that jumps out to you? You see the two or more equations? There is a certain pattern.
Oh, there's two.
What about the twos?
The same. They're opposite.
Okay, so listen, you need to hear this and hear this well. So if you ever have those moments where you like sort of tune out or zone out for like 30 seconds, 40 seconds, don't let that be this next 30 seconds, okay? Here we go. Notice how the twos, the coefficients on the y's, one of them is positive 2, and the other one is negative 2. What is negative 2 plus positive 2? 0. And 0 would mean that like the term has been eliminated, right?
Yeah.
So I want you to think about this thing I like to refer to as the pattern of opposites. Somebody said opposite earlier. Negative 2 and positive 2 are opposites. So here's how we do this. I recognize that those are opposites. I'm going to put a little line down here, and I'm going to add. I'm simply going to add up, vertically speaking, the different terms, the different like terms in this system. So if I add vertically, what is 4x plus 3x? 7x. What is negative 2y plus 2y? It's 0. Or you could just say the y's have been eliminated. There we go. The equal sign does not go anywhere. 22 plus 20 is 42. Pretty easy looking equation to solve now, right? What would I need to do? Divide by 7. Divide by 7. I get x is equal to 6. Pretty fast, huh? I got to say, substitution has its moments when it's pretty useful. Hold on. I personally favor elimination a lot of the time. Why would you say y equals 0? Well, no.
So would it be just y?
We plug it back in. Remember how we did that with substitution? We're going to take that x equals 6, and we're going to plug it back into one of the two equations we have. So, hey guys, please make sure you get this. I'm going to turn you loose in a minute or two here. See if you can do this on your own. So once I get that first answer, to get the y that goes with that x, I'm going to plug back in. I can choose either one of them. It doesn't matter. I think I'll just choose the second one. So I would write 3 times 6, because I know that x is 6, plus 2y equals 20. So I'm just taking that 6 and I'm plugging it back into my system. And now I'm going to try to solve. What would you guys suggest be my first step?
Multiply
18.
Okay, I could multiply 6 times 3 and get 18. Sure.
2y equals 26. And then you do
Shh.
minus
Hold on.
18.
I'm so sorry. You're just getting a little ahead of where Mason is asking about. Where did I get the 6 over here? I used elimination. Do you see over there it says x equals 6? And then what I did is I took this equation that I'm highlighting in yellow. And do you see how I took that and I wrote it over here? Oops. And instead of writing 3x plus 2y ... I wrote 3 times 6 plus 2y. And I'm allowed to do that because I already figured out that x is 6. Okay, now what would you do as far as the step? You were saying something, Ellie?
Minus 18.
Okay, minus 18. Bray, what would be your next step?
Divide by 2.
Perfect.
So it would be y equals 1.
It would be y equals 1. So remember that you all said this earlier, a lot of you did, the solution to a system is the point where the lines intersect, right?
6, 1.
So it'd be 6, 1 for my final answer. So elimination works when you have the pattern of opposites. You have to have the pattern of opposites for elimination to work. In this case, it was negative 2y and positive 2y. That was your pattern of opposites. Sometimes we're not going to have the pattern of opposites, and we're going to have to make it happen. Okay? Anybody have any follow-up questions, clarifying questions on anything you've seen here? Okay. So why don't you look at number 2? And I'll kind of get you started, and then I'll let you try to run with it. So, well, let's talk. Hey, let's talk first. I want to get you started. Once you get you set up for success, look at your x's. Look at your y's. Do you see a pattern of opposite coefficients like you did in number 1? No, we don't. Like there's no plus 2y, negative 2y. Is there anything in this that's pretty close to being the pattern of opposites?
Plus and negative.
Be a little more specific. Say again?
Negative 6x.
Yeah, the x's both have a coefficient of, I heard somebody else say it. Well, one of them is 6x and the other one is 6x. Are you with me? Come on. I want to at least get you started here. Well, so here's the problem.
6 is
Hey, feel like we need to all be on the same page. So for those of you that are kind of doing your own thing, please stop. I want to make sure you get this. If I were to add right now, and this is, Sebastian, kind of what you brought up, I think. If I were just to add these up right now, wouldn't I get 12x plus 12y equals negative 108? Yeah, negative 108. Has anything been eliminated?
No.
So have I used elimination? So this is not going to work for us. I need to do something a little bit different. What could I do with my x's to create that pattern of opposites?
Change one of them to negative.
One of them, if I could make one of them negative, that would be great, right? But I can't just do this. I can't come over here and say, all right, 6x plus 5y equals negative 49, and negative 6x plus 7y equals negative 59. Ah, okay. What rule have I broken, Sophia?
Oh, well, I was just going to say that you can just subtract.
No, don't say that yet. I don't want to mess people up. You're not wrong, but that tends to mess people up big time. Okay? What do you see, Bray?
Can't you multiply negative into one of the 6x's?
Yes. What rule have I broken when I wrote this? Because I've broken a big algebra rule, haven't I, Ella?
'cause it was-
We have to do it for all of them.
Yes. I can't just go in and pick one that I want to change and leave the other ones the same. I need to do what you suggested, right?
So for one of those equations, you could just times it by negative.
Negative 1. Yep, that's exactly what I'm going to do. So I'm going to take this bottom equation, and I'm going to say I want to multiply it by negative 1. And that means I got to multiply every single term. This goes to Ella's point. I got to multiply every single term through by a negative 1. So that's going to give me negative 6x minus 7y equals positive 59. Now, do you see the pattern of opposites showing up on the x's?
Yeah.
This is where I want you guys to try to take over. See if you can start there and finish out and get your point of intersection between these two lines. I'll be around. Let me know if you need help. Yes, ma'am.
Can't you just subtract it all?
Okay,
and
so-
not do something?
Yes. I've done this long enough to know that if I present two options that look similar enough and they're both correct, people screw them up. They mix it, they get this ugly hybrid of the two.
Okay.
So I'm just going to present elimination as simply an addition process.
Okay. So would you rather me do that? Because
No, I want you
learned
to
it
do
as
something that
subtraction.
mathematically makes sense, and if that mathematically makes sense and is valid,
Okay.
I'm fine with it. Truly am. But what I don't want to do is I don't want to present two options
Okay.
at this point because most of your classmates have not seen this before, and so I just want to show them one really good option that works.
Okay.
If you can be flexible in your thinking and do both, all the better.
Okay.
Let's see here. This would be negative 2y equals 10, so y equals... So y should be negative 5. And... No, x is definitely not 0.
Why is y negative 5?
So I've got my pattern of opposites here, right? Add them up, I'm going to get 0. Oh, this is not 1x, this is just 0x, which is just 0. Isn't this negative 2y?
Yeah.
Negative 2y, so write it. Equals. When you add these up, what do you get?
10.
Yep. Now get the y by itself. Perfect. What does y equal?
Negative 5.
Put y equals. Don't have a floating. Perfect. So that's why I would say what I said. Now, once you've gotten one answer, like this, how do you get the x that goes with that y?
You have to plug it in.
Plug it back in. There you go. Okay, I'm seeing some stuff. Don't ask me what the answer is. Okay. I don't even want to go there. Like, I don't want to make that like an option for people. So if you want to talk privately about that, I mean, you certainly can do that. I am not going to present that as like, hey, do this or that. People screw it up. I've just seen it too many times. We're like, wait a minute, you said, and I'm like, yeah, you weren't listening. So I want to keep it super simple. Okay, Isa's not there yet. No, she is there. Oh, you're more than there. You're like trying the other one. Have you guys checked your answers together? Okay.
Tacos per second.
Yikes. Sasha?
Oh no, I wrote that down. What you do is you have to transfer the negative to all of them so that you can eliminate. Because if you don't do that, then it's not elimination. And then you get that. And then you get 12y equals negative 108.
No. See, I did it too. I did that too.
2y.
This sounds like someone who's been just jacking around for the last 5 or 6 minutes and is trying to backpedal and recover.
No, I
Right?
just messed that up.
I don't think so. Like you,
Yes, it is.
No, it's not. Watch.
Sasha, look at me.
So you go.
You sat here and drew a picture for the last 5 or 6 minutes, and you're telling me that you haven't been screwing around?
No, I'm just like not having a good day.
That's a choice you can make.
Negative 49 minus
Should we tell
negative 59
Sasha?
makes it plus.
Oh, I see what you
Hey,
Learn from experience.
hey guys, let me present a solution. And wouldn't it be awesome if my solution and your solution all matched and we all thought, hey, we all got it? Let's try it. So when I add 6x plus negative 6x, I get 0. So I could write a 0 down there, but I typically don't write anything because the x has been eliminated, right?
Yeah.
Come over here, I add these two up, I get negative 2y,
Equals 10.
and that equals 10. I want to get the y by itself because I'm trying to figure out what the y and what the x are. So I would divide everything through by negative 2, and this would give me y equals negative 5. How are we doing?
Perfect.
So I have like half of my answer, right? I need to get the x that goes along with that y. So I heard somebody say it. What do? You plug it in. So it doesn't really matter where you plug it in. I'm just going to plug it into one of these two. I'm going to say the top one. So this would be 6x plus 5, but instead of a y, I can put negative 5 equals negative 49. And then I solve. So this would be 6x minus 25 equals negative 49. And hopefully this is looking really familiar to you at this point. What do I need to get rid of next?
The negative 25.
And how do I do that?
Add 25.
That's right. So I go plus 25, plus 25. This gives me 6x equals negative 24. And what's my final step? Yeah, dividing gives me to that negative 4. So x is equal to negative 4. So my final answer would be over here, negative 4, comma, negative 5. In parentheses, that's right. I hope that went awesome for you. Is it okay?
Yeah, that went great.
Fantastic. Okay, so the rabbit hole does go a little deeper. Let's go there. So if you guys would flip over to our next page, and we'll do a little more elimination here. Yep, this is a good one. Practice 2. And again, I want to kind of get you guys started, and then I'll have you finish. In order for elimination to work, you need to have the pattern of opposites. Which variable, the A or the B, which one has the pattern of opposites right now? None. They don't. Neither of them does, right? It's 3A and 4A. Those are not pattern of opposites. In fact, they're not even the same number, are they? And then the B's have coefficients of 5 and 3. Clearly not a pattern of opposites. And they're not even the same number. I would say that this represents the most challenging version of elimination. Okay? I need the pattern of opposites, but I don't have it. And I'm a lot less close than I was on the other one, right?
Why?
Well, so the pattern of opposites would be this: 10 and negative 10, 8 and negative 8, or negative 15 and positive 15, or 20 and negative 20. So they need to be the same number, but opposite signed, right? So I look up there and I've got 3A and 4A, clearly not that pattern. I've got 5B and 3B, again, clearly not that pattern. So I'm wondering if anybody has any suggestions at all about what we could do. What do you think, Bree?
Well, it's kind of like a fraction. You got to make it so you got times. I don't know how to explain it, but I just know how to do it.
Can I fill in the gap with a phrase?
Yeah.
Least
Common.
Hey, there we go. It's a least common multiple concept, which is kind of like what you're talking about with the fraction thing.
Yeah.
Okay, so do you have any thoughts on least common multiples in this one?
We got to do a negative for one of them.
Okay.
So
I hope, guys, she's explaining this really well. I hope you're listening. Keep going.
I would do A, so I would do 12, which would be times the bottom row by 3, and then times the top row by negative 4.
Okay, so you said multiply the top row by negative 4?
Yeah.
So negative 4 times the top row, and what did you say about the bottom row?
Times 3.
Times 3. So let's just ponder this for a second. She has led us to a good place. But let's talk about kind of the whys and the hows of this. I'm pretty confident, based on the way she responded, that Bree probably knows a little bit about why she did this. Can anybody else maybe figure out, maybe explain a little bit, like why on earth did she pick negative 4 and 3? Like what's the deal? What do you see, Mason?
Negative 4 because that's the opposite of positive.
So we're establishing a negative positive thing.
Yeah.
Agreed. Bray, keep going.
She took the 2 A's and flipped them over, and then added the negative 4 because it's a positive.
Okay, yeah, to create the negative positive thing. Okay, that's a great pattern. That's exactly what you want to see. What else do you see?
I have a question.
Okay, go ahead.
Why didn't you do a negative 3 instead of a negative 4?
Oh, did you hear that? He said, why didn't she do a negative 3 and a positive 4 instead of a negative 4 and a positive 3?
Does it matter?
Does it matter?
No.
It really doesn't matter. If that's what struck you, like, hey, I think I'll do it this way, it would have worked out fine. It would have. Keep going. Other thoughts, observations? Yeah.
So then you get the same negative.
But opposite, right? Exactly. So let's see this taking shape. If we take Bree's idea, the top row would be negative 12a minus 20b is equal to positive 4, right? Because a negative times a negative is a positive. And then the bottom row would be 12a plus 9b equals 18. Now that you can see them multiplied out, can you see why Bree picked the numbers that she picked? Do you see the pattern of opposites with the a's? Let me bring it all the way back around to Bray's idea. He said, I noticed how she multiplied the 3 by a 4 and the 4 by a 3. He said, basically, she switched the 3 and the 4 on the multiplication. That'll always get you to the place you want to be. Just make sure the signs are opposite, right? Okay. So I'm hoping now, this being our third one, I'm hoping you guys can bring it home from here. Okay? So if you haven't already started in that process of elimination, please do. So now that we got this pattern of opposites set up nicely, I would just add, and I would get negative 11b is equal to 22. Solving by division with negative 11, I come up with b equals negative 2. Okay, so I have half my answer. How do I find the other half?
Plug it in.
Plug it back in. So I take that negative 2. Somebody asked a question. I think this is worth posing to you guys. Do you guys realize that there are 1, 2, 3, or 4 equations that you could plug back into? You have 4 options. Which 2 are the easier 2?
Bottom.
The top one.
Yellow and red.
Yellow and red, yeah, the top ones. Those would be the easier ones simply because the numbers are smaller, but you could honestly use any of those, and it should give you a good answer. So I'll just plug into the top one. This would be 3a plus 5 times negative 2 equals negative 1. Do a little arithmetic here. 3a minus 10 equals negative 1. Add 10 to both sides. I'm coming up with 3a equals 9. And so my final answer would be a equals 3.
Yes.
So my final answer would be 3 comma negative 2. How are we doing? Okay. This might seem strange. We're going to finish on kind of a weird note. Will you look at number 2?
Yes.
Number 2 is a little strange. But this will make you think. This will get you ready for some web-assigned questions you'll see coming up.
But then it would just be.
Number 2 is weird. Try it out.
Wait, is tonight's web assigned homework 2? Because
I wish I could have all those things memorized, but I don't.
because I did 2 last night.
It is 2.
It's 2 tonight.
You can do tonight.
So are you ahead?
Well, no, because I did 2 instead of 1 on accident.
Oh, gotcha. Gotcha.
So then you just need to get next time to know 1.
Yeah, if you want to do that, just send me an email.
Okay.
Yeah, no.
Has anybody gotten to this weird place that I referred to?
Well, it's like they both cancel out.
Yeah. We're going to get there. Hey guys, let's talk about the weirdness of this one. Please listen. Did you notice the pattern of opposites on the x's?
0 equals 5.
Hold on. Did you notice the pattern of opposites?
Yeah.
And did you notice how the y's had a very similar pattern of opposites?
Yes.
So we didn't have to do any special work like we did on the other ones to get to that pattern of opposites. So I could just add right here. This is where people get tempted to do some really wrong things because this is weird, right? So Mason, this is where you get lost.
I did not get
No, you're talking to Chase, and I'm doing my darndest up here to help you, and you're talking to Chase, right?
right.
Yeah. Okay, so when I add 6x plus negative 6x, don't I just get 0? All right, so that's 0. Plus, what happens when I add the y's up?
0.
It's a little bit unexpected. Didn't both the x's and the y's get eliminated here?
Yes.
This has not happened yet. That's why I say this is a little bit weird. Equals, what's 4 plus 1?
5.
And of course, 0 plus 0 is just 0. So we end up in a very weird place where the x's and the y's both got eliminated, and I get this really odd statement of 0 equals 5. So,
It's untrue.
first of all, we have to establish that that's not true. 0 does not equal 5. And so I'm going to come back up here and say that. 0 doesn't equal 5. And we've seen situations sort of like this before, where the x's and or the y's get eliminated from the equation. And we get a statement like this. And anytime the statement resulting is false, like this one, what's our conclusion?
No solution.
No solution. That's right. Well, I wanted to make sure we got there through a good path, and I didn't know if you just guessed it or not, but you're right. Can I show you one last thing?
Sure.
Please check this out. I'm going to take the top equation, and I'm just going to do this real fast, but you need to pay attention because this is so good. You're going to make a good connection here. Y'all okay with this? Please watch.
No.
I subtracted 6x from both sides. Okay, sorry, I was skipping steps.
Oh, yes.
I will stop skipping steps.
Oh, I saw it.
I did not see it.
Ah.
See that?
Yes, sir. Negative 4y equals 4 minus 6x.
See it?
Yes, I understand.
Guys, if you're just sitting there chatting, you are doing the exact wrong thing. So what form is this? Slope intercept. Slope intercept form. So I did that with the top line. Okay, now watch this with the bottom line. Negative 6x plus 5y equals 1. So I'm going to do a very similar thing. I'm going to go plus 6x, like so. I'm going to get 5y equals 1 plus 6x. Then I'll divide by 5. I get y equals 1/5 plus 6/5 x. So those are my two equations. They're the exact same equations that came from my system. I've just converted them to slope-intercept, right? Does anybody notice anything interesting about these in slope-intercept form?
X is second.
It's same yeah. I mean,
Something's the same.
Same bottom. Same Y.
Slope. Did you notice that the slopes are the same? There. Okay, so if the slopes are the same, but the y-intercepts are different, what kind of lines do we have? Now, this is where you're going to make the great connection. What is a system of equations? Mason, what's a system of equations? Swing and a miss. What's a system of equations? Listen.
Two equations that are graphed on the
Did you hear it, Mason?
equations graphed together.
Two equations graphed together. What? Please don't pack up. You're going to miss the awesome connection. Please don't pack up.
Okay.
So a system is two lines graphed together. What is a solution to that system, Doc? What is a solution? What is a solution to the system?
Two lines graphed together.
It's yeah. The point where the lines intersect or cross. Now, do parallel lines cross?
No.
So should there be a solution to this? No. Do you get it? Yeah. Awesome. Yay. See you tomorrow. Have a great day. Thank you.